Today we'll be covering exercise 1.2 mathematics class 8, that is rational number, right? So let's start with question number 1. I have also written down question number 2. So the question is, represent 7 by 4 in number line. Okay, so in previous classes you have already covered what is number line, and we all know to represent integers on number line. On the left hand side of 0, which is considered to be the center of number line, are the negative integers. On the right hand side are the positive integer. Same principle is followed in case of rational number. Okay, so let's do our number line first. So this is a straight line. Now I mark here as 0. Okay, now this is we have to represent 7 by 4 on this number line. Numerator is 7, denominator is 4. Numerator is greater than denominator. While representing rational number or number line, the denominator represent, just like fraction, it represent the part of which the numerator is. Okay, so you can see this is a mixed fraction, and we can write this as 1 3 by 4. Correct? Now as we go, this is in this side negative integers or rational number represented, and this side positive. Okay, as you go from here, so what is this denominator indicate? It is part. Okay, it is part of which the numerator is being taken, right? So we'll divide this number here. Okay, we'll represent 1 here, we'll extend bit, or we'll represent 2 here. Okay, now we can see, if we write here, we can write, if we divide this part into 4 equal parts. Okay, this from 0 to 1, we divide it into 4 equal parts. One part, second part, third part, and fourth part. So this first part becomes 1 by 4, correct? Second become 2 by 4, third become 3 by 4, and this one is 4 by 4, that is 1. Correct? Similarly, in this number line, as we go further, we will divide from 1 to 2 again into 4 equal parts. First part, second part, third part, and fourth part. Okay, and this is the direction of number line. Okay, now what is, how you will represent this one here? 1 is covered, so you can represent it in terms of mixed fraction as 1 and 1 by 4. Okay, so this becomes nothing but 5 by 4. This is 6 by 4, correct? This is 7 by 4, and this 2 is nothing but 8 by 4. 8 by 4 is equal to 2, right? So this is how a number line progresses. Now you have to represent 7 by 4. Why is 7 by 4? This is 7 by 4, correct? So on this number line, you have divided from 0 to 1, and thereafter 1 to 2, thereafter 2 to 3, then 3 to 4 in 4 equal parts, because denominator is 4. Okay, and from this part you have taken 7 by 4. Where does this exist? This exists on the right hand side because it is positive, and here is the location. Correct? Now next question is, you have to represent minus 5 by 6 on a number line. Okay. Minus, it will be on the left hand side. So we draw number line. We mark 0 here. This is positive side and this is negative side. Okay. In this case, how many parts you are going to divide? Denominator 6. So you are going to divide. Say up to, we put 1 here. This is in fact minus 1. From 0 to minus 1, you have to divide this number line into 6 equal parts. Okay, because denominator is 6. Correct? So first part, second part, third part, fourth part, fifth part and sixth. Okay, 1, 2, 3, 4, 5, 6. So you have divided this line into 6 equal segments which represent each part from 0 to minus 1. Correct? Minus 1 is shows the direction that is on the left hand side of the number line. Correct? Now this will be minus 1 by 6. Okay. This will be minus 2 by 6. This will be minus 3 by 6. Minus 4 by 6. Minus 5 by 6. And this will be minus 6 by 6. Okay. This equals to nothing but minus 1. Correct? So where is the location of minus 5 by 6 on this number line? It is here. Okay. Moving on. The next question is, we have to represent minus 2 by 11, minus 5 by 11, minus 9 by 11 on the number line. Same way, we again draw a number line. These are all negative rational number. So our approach will be towards left hand side. Denominator is 11. So we are going to divide this each segment from 0 to 1 into 11 equal parts. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Okay. So here will be minus 1. Okay. So let's number again. This will be minus 1 by 11. First part. Minus 2 by 11. Minus 3 by 11. Minus 4 by 11. Minus 5 by 11. Minus 6 by 11. Minus 7 by 11. Minus 8 by 11. Minus 9 by 11. Minus 10 by 11, and this is minus 11 by 11, that equals to 1. Correct? So let's see where all these numbers are located. We want minus 2 by 11. Here it is. Okay. We want minus 5 by 11. Here it is. We want minus 9 by 11. Here it is. Clear? So while representing rational number on number line, we divide each segment, that is an integer, a segment of an integer, into equal parts, that is decided by the denominator. Okay, because numerator is part of that. And similarly, as we deal in integers, on the right hand side there will be positive rational number, on the left hand side there will be negative rational number. Clear? Let's move on to question number 3. 5 rational numbers smaller than 2. Question is, this is I've already made this number line. We have to find 5 rational number which are smaller than 2. Okay. Now, anything on the left side of 2 will be smaller. So we don't have any problem. We can take negative rational number also and positive rational number also. This is 1. And this is 2. So suppose we divide this into this segment into 2. Similarly, we divide this segment into 2. So what will be location? What will be this rational number? This will be 1 by 2, and this will be 2 by 2, that is 1. Okay. Similarly, this will be 3 by 2, and this will be 4 by 2, that is 2. So 3 by 2 is smaller than 2, one number we have got. 2 by 2, second. Third is 1 by 2. Fourth is 1 by 0. These are all smaller than 2. So you can see, similarly, if we divide again into equal parts, we will get more rational number which will be smaller than 2. So this way, between any two numbers, there can be n number of rational number. So choice is yours, whatever you want to put in your result. Similarly, this will be minus 1 by 2, and this will be minus 3 by 2. Okay, so on. So whatever number you choose from here to the left side, they will be smaller than 2. You pick up any answer, it will be correct. Clear? Okay, next move on to the next question, which is very important. Okay, question is, we have to find ten rational numbers between minus 2 by 5 and 1 by 2. Okay, now let's see the first number line I already made. Here lies 1 by 2 and here lies 2 by 5. Okay, so we have to find 10 rational numbers between 1 by 2 and minus 2 by 5. So here you got only 1, you can represent this, you can divide again into half, so this will become 1/4 this way, but finding 10 is tough with this kind of number line. So I have again made another number line. In this case, I have taken LCM, and LCM is 5 into 2 is 10, and I have divided each segment into 10 equal parts. Okay, this is first part, second part, like that. So here lies 1 by 10, here lies 2 by 10, 3 by 10, 4 by 10, 5 by 10. 5 by 10 is again 1 by 2. Okay, and if you move on the left hand side, this is minus 1 by 10, minus 2 by 10, minus 3 by 10, and minus 4 by 10. Here lies minus 2 by 5. Okay, so we have to find 10 rational number between these. Correct? Let's count. First one, 1, 2, 3, 4, 5, 6, 7. On this number line, if we represent as taking LCM and dividing each segment based on that into 10, we are only able to get 7 rational number which lies between minus 2 by 5 and 1 by 2. Correct? But we want how many? 10. So we have to further divide. We have to find more number in between. How can we do that? We can divide each segment into more parts. So what I have done, I have multiplied with 2. So this time we have divided each segment from 0 to 1 into 20 equal parts. So here lies 1 by 20, here lies 2 by 20, 3 by 20, like that, and 10 by 20. Here lies 1 by 2, and on this side minus 8 by 20. Here lies minus 2 by 5. As for our question, we need to find 10 rational numbers between these two. Correct? So let's count. So we can make 9 by 20 one rational number, then 8 by 20, 7 by 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, like that. 16 number we have got. You can choose any 10 out of it. So idea is that when this kind of question come in exam, you should take a larger denominator so that you can get more equal part, that means more number of rational numbers. So you won't have to repeat this. Correct? So here was one repetition. Suppose if I didn't have made effort for this number line, straight away I could have got more than 10 rational number. Again, you could have this could have been transformed into 40, denominator 40, and you can count more number of rational number. Correct? So idea is that in this kind of question, we should take a larger denominator and find requisite number of rational number. Clear? Let's move on to the next question. We have to find 5 rational number between 2 by 3 and 4 by 5. Okay. So this time I'll try to explain without the number line. That will save time, and for you the calculation will be faster. Okay. So let's see. We take denominator as the LCM. So we make it 15 here, and 2 by 3 will be, we take LCM, so 2 by 3, here we multiply it by 5, here we multiply it by 5, and it becomes 4 multiplied by 3 and 5 multiplied by 3, denominator common, that is 15. So here we get 10 by 15, and here we get 12 by 15. So how many number can you represent comfortably without taking any further break? Is after 10 comes 11 by 15 and 12 by 15. So with this modality you are not able to achieve requisite number of parts. So 15 is not enough, right? If we have to find 5 rational number between these two. Okay, so let's move ahead, and we'll further increase, multiply by 2. So in this case this will become 20 by 30, and this will become 24 by 30. Let's move on. Let's find number between 20 by 30 and 24 by 30. We'll try a bit apart, 24 by 30. So we can get 21 by 30, okay, 22 by 30 and 23 by 30. Again we have managed to get only 1, 2 and 3 rational number between these two, that is 2 by 3 and 4 by 5. Okay, we need 5, so we have to further increase the denominator. So let's again multiply this into 2, and this will become, okay, this will become 40 by 60. We multiply by 2 here and 2 here, so this will become 40 by 60, and 4 by 5, this will become 60 and 48. Okay, this is same as 4 by 5. Let's see, can we get 5 number between these two? We have got 41 by 60, 42 by 60, 43 by 60, 44 by 60, 45 by 60. So I've got 1, 2, 3, 4, 5 requisite number of rational number, and we also have 46 by 60 and 47 by 60. So we have got 7 rational number between these two. So we could get the result in third attempt by increasing the denominator, that is on the number line we have increased the parts between 0 to 1 or any other further segment. Correct? So let's move on to the next part of it. We have to find again 5 rational number between -3 by 2 and 5 by 3. This is, of course, we have got more room because we have seen in other questions that we have got both sides to move. Okay, so let's start with, we can make 3 by 2 minus 3 by 2. We can multiply it, we take LCM straight away. So this LCM is 6, so multiply by 3 here, multiply by 3 here, and we get how much? Minus 9 by 6 here, and we write 5 by 3, we want 6 as denominator, so we multiply with 2, and here we get 10 by 6. Okay, so we just want 5. Let's move to the right hand side. So here we're starting from minus 10 by 6. On the number line, suppose you just can draw a number line here. Just imagine you are moving from left to right hand side. So we'll get 8 minus 8 by 6 minus 7 by 6 minus 5 by 6 minus 4 by 6 and so on till 0, and from here you will get, I've got 6 equal parts here, so somewhere here you will have 1 by 6, 2 by 6, 3 by 6, and reach here as 5 by 3 will be 10 by 6 will be somewhere here. So you got so many number, so you can choose any out of them, minus 5 by 6, 1 by 6, 2 by 6, like that. So this is how you find out rational numbers between two rational numbers. Okay. Let's move on to the final part. Here we have to find 5 rational number between 1 by 4 and 1 by 2. Right hand side. So so we have to take as much possible a larger denominator in this case. Okay. So 4, 2, we can make it 8, we can make it 16, let's try making it 16, okay. So for 16 denominator you have to multiply by 4, you have to multiply by 4, okay. Here you have to multiply by 8 and here to multiply by 8. Let's see, so this becomes 4 by 16 and this becomes 8 by 16. So moving on to the number line, we will get 5 by 16 and 7 by 16 and then straight away 8 by 16. So you don't have much room. Okay. So let's try by increasing further. So we'll make it, let's make it 32. To make it 32, we'll again multiply by 2, multiply by 2, here we multiply by 2, here we multiply by 2. Okay. So let's see what you get. This becomes 8 by 32. Okay. And here we get 16 by 32. Okay. So let's move on to the number line. On the right hand side, you will get 9 by 32, 10 by 32, 11 by 32, 12 by 32, 13 by 32, 14 by 32, and 15 by 32, then 16 by 32. So you have got 1, 2, 3, 4, 5, 6, 7 rational numbers between 1 by 4 and 1 by 2. This is nothing but 1 by 2. Okay. This is nothing but 1 by 4. Correct? So let's move on to last two questions of this exercise. We have to find 5 rational numbers which are greater than minus 2. Okay, so let's draw a number line. This is 0 and somewhere there will be minus 1 and here this will be minus 2. This will be 1 and this will be 2. Positive direction, negative direction. Okay, so it's in fact very easy. We don't have to apply much of brain. If we divide this into equal parts, this will be somewhere 1 by 2 and this will be, we have to divide into two parts, first part, second part, and this will be 3 by 2 and this will be fourth part, it is 4 by 2. Okay, and here we have got minus 1 by 2 and minus 3 by 2. So this much, from this we can choose 5 rational number which are greater than. So we all know that number line moves from left to right direction as far as it increases. Okay, so you can choose this one, this one, this one, and this one, this one, this one. So these all are numbers which are from left hand side to right hand side of -2, hence are greater than -2. Okay, you can further increase it. Suppose there is 3, so you can again divide it into 5/2. Okay, this becomes 6/2, that is 3. So you can take 5/2 also this way. Clear? Let's go on to the last question. We have to find 10 rational numbers between 3/5 and 3/4. Okay, so if you see, the gap is very less. So we apply this principle, we need 10 numbers. So let's take a larger denominator, because 3/5, 3/4, they are very adjacent to it. Okay, just imagine on the number line where they exist, if you divide into, say, you take the LCM, then you divide into 20 equal parts. So let's see, can you get it? If we divide, make it 20, so 3/5, we take LCM, we make it 20, that is 4 into 4, so this become 12/20, and here 3/4, we can make it 20 by multiplying 5, 20 as denominator, so we get here 15/20. Okay, so from here, if we start taking numbers, 13/20, 14/20, 15/20, we finish off here. Okay, only two we are able to get. So let's jump a bit so that we get the results soon. We can we can make it 80 also. Let's start with 80. Okay, so 3/5 into, say, multiply by 16. Okay, 16 5s are 80, and here we multiply by 16, here we multiply by 3/4, we multiply here with 20, here with 20, so that we get 60/80. Okay, and here we get 48/80. So should we move? So 48 and 60, between that we have to find out. So 49/80, 50/80, 51/80, 52/80, 53/80, 54/80, 55/80, and 56/80, 57/80, 59/80. How many have got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have managed to get 10 rational number between 3/5, that is 48/80, and 60/80, which equals to 3/4. 16 5s, 16 to the, this is 3/5. Okay, so we have just managed to get 10 rational number between 3/5 and 3/4 by making denominator 80. You can take larger one. In the book, the answer given is 160. To be on the safer side, you could have taken a larger denominator. So probably you will get more than 20 number between these. Okay, so it's better always to solve fast. You take reasonably larger denominator and get the answer in the first shot. Hope you understood. This was very important, and in the next class we will be moving on to the next chapter. Okay, thank you. Keep practicing.